I'm Mr. Richmond, and this is your Unit 13.3/13.4 Lesson Summary. In Unit 13.3 and 13.4, we'll be looking at some shortcuts to prove that triangles are congruent. In 13.3, focus on the side-side-side congruence theorem, and in 13.4, you'll take a look at side and angle side. So I have a couple problems here that we'll work through to show you how we might show triangles are congruent using these. Before we do too much with that, I just want to do a brief explanation of the two theorems. In the book, you get into it much more, so I definitely suggest looking at the first two problems in the book here, because you'll actually do constructions to prove that these are true and that they work. But the side-side-side SSS congruence theorem states if you know that the corresponding sides of two triangles are congruent for all three sides, then the triangle must be congruent. And the way you can kind of prove that is if you take three different lengths and you try to recreate them in any way, the only way that they'll go together is in a way that allows the triangles to actually stay congruent. So if I have triangle ABC and triangle DEF, and they correspond like so, ABC to DEF, and AB is congruent to DE, BC is congruent to EF, and AC is congruent to DF, then the triangles must be congruent. That's what side-side-side is stating. Our other one is side, angle, side, SAS, side, angle, side, and again you show this being proven by giving you a side that they want you to keep, an angle, and then a side, and you try to make different triangles with it, and you discover, hey, all the triangles are the same. So in that one, the things you'd be given, I'll just do ABC again to show you, would be a side, an angle, and another side. And so if I tried to recreate that triangle anywhere using the same exact measures for the first side, angle, and side, the triangles would have to be the same. They'd have to be congruent. The thing you have to look out for when using side, angle, side, though, is that the angle is between the two sides that are congruent. So if you have side 1 and side 2, your angle has to be between those. Side, angle, side is inside of it. And so one way we can use these is just by on a coordinate plane measuring it. Measure the lengths, take a protractor, measure the angles. Maybe there's a right angle there. Find that as the angle to prove side-side-side. So I have to find this information. The other way we'll do it is in a plane. So a non-coordinate plane. It's not going to actually be labeled. And we don't really know side lengths, but we have to use some logic to prove things are congruent. Some common ways we'll do that. That's really ugly there. But if I drew something like this, then this side of this triangle and the bottom side of this other triangle are congruent because they're sharing it. So that's one thing you'll see a lot is they'll share a side, so you know automatically then that those sides are congruent. So you'll have to use a bit of logic here in this section, but we don't get anything too crazy yet. We just want to get you comfortable with using these couple of triangle congruence theorems. So it's side, 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 where corresponding sides are congruent, and side, angle, side, where a corresponding side is congruent to its corresponding side, the angle in between is congruent to the angle in between, and a second side is congruent to the second side. So let's take a look at what that might look like in terms of a problem. So the first one I'm going to do here is say, determine whether the triangles are congruent using side, side, side. So they actually want me to use side, 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 which means they want me to try to find all the sides, corresponding sides, see if they're congruent. So the best way to do that is to actually find the measure length of all the sides in the problem. So I have EF, ED, and FD on this side. And some of these you can get easy. If they're horizontal or vertical, you're allowed to just count it. So if I count EF, it's 1, 2, 3, a length of 4. If I count ED, it's a length of 1, 2, 3, 4, 5, and 6. And I don't know FD, but I can get that one of two ways. I can do the distance formula, or I can do Pythagorean theorem. It's okay to do either one. So it's the square root of 4 squared plus 6 squared. 4 squared is 16, 6 squared is 36, 6 plus 6 is 12, so that's 52. So it's the square root of 52 is the length of FD. Now what I'm hoping is that all three of the corresponding sides of triangle ABC will match one of the sides on this one, and then I'll know that they're congruent by side, side, side. So now I'll find the measure of AB. That looks like it's 1, 2, 3, 4, 5. Measure of BC is vertical, so I can just count that. 1, 2, 3, 4. And then to find the measure of AC, I would have to do the Pythagorean theorem or the distance formula again. If I do that, it would be, this was a length of 5 and 4. So it would be 5 squared plus 4 squared. 5 squared is 25. 4 squared is 16. Making the length of AC 25, 35, 41. It's the square root of 41. And so as I look to kind of correspond, I can see that EF and BC are congruent at least, but the other two lengths are not. So because they didn't all match up in length, these triangles can't be congruent under the side, side, side formula. So I'd say no side, side, side congruence theorem does not work, or does not hold. And that's because as I found the lengths, it didn't work. To prove that they were congruent, I have to actually show that all these corresponding sides are congruent. So you show your work with this via the distance formula. Okay? Let's try one now that's not on a coordinate plane. It says here, prove the triangles are congruent using side, 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 or side, angle, side. Write congruence statements to justify your reasoning. So one thing I'm going to look for you to do here is actually mark up the diagram. And for some people, it helps to draw the triangles out separately as well. So I'll do that first as well. So I have triangle A, B, C. That's the bottom left triangle. And when I write it separate, and these aren't going to look congruent, because I'm not drawing them really to scale here, but I have A, D, C. And that's the two triangles with the problem. A, B, C. Is it congruent to triangle A, D, C? So I start to look at the measures. I have side AB is 10, side DC is 10. That means side AB must be congruent to side DC, so I'll mark that with a congruent symbol. They tell me that angle BAC is congruent to ACD. So I'm going to mark that with a congruent angle symbol. And then the only other thing, they don't give me the measure of AD. I know it looks like it's congruent to BC, but they don't give me the actual measures, so I can't prove that those are congruent to each other. But they do share side AC here. This side must be congruent because they're the same side. So AC, actually I guess I could use 2, because I only have a second congruent side. Must be congruent to AC. And again, they're the same segment name in the same problem, so they should have the same length. And now if I look at it, I have on this triangle, when I go from 1, I go side, angle, side. It is in between them. Side, angle, side. It is in between them. I have enough information now to prove that these triangles are congruent. So I can say side AB is congruent to side DC. Angle BAC is congruent to angle DCA, and I can say side AC is congruent to side AC. So triangle ABC is congruent to triangle ADC by the side angle side congruence theorem. So again, to use the actual theorem, I have to find side, angle, side, or side, side, side. I have to find all that, and I have to label what is congruent to what to use that and to prove it. So I did side, angle, side, proved it. Let's try the other one. Here I have triangle ABC, and so again, I'm going to draw them separately. A, B, C. And here I have triangle ACD or ADC. And I'm going to start marking congruent parts. Again, I didn't draw to scale. I know I went quick there, but there you are. Supposed to match what's here. They said side AB is 10 and side CD is 10, or AD is 10. So those two are congruent, so I'm going to mark them. On the bottom I have BC is congruent to CD. I'm going to use the second tick mark for those, because those are 5 and 5. And AC in this diagram is shared by both. So AC must be congruent to AC. So I can give that 3 ticks. And now I've got side, side, side in triangle 1, side, side, side in triangle 2. I have enough information now to say the 2 triangles are congruent. So I have to list it, and I have to make sure I match them correspondingly correct. So AB, side 1, is supposed to be congruent to AD, side 1. BC is congruent to CD, and AC is congruent to itself, AC. So I've listed that. They've got 3 sides corresponding, so now I can use the side angle side. So triangle ABC is congruent to triangle ADC by the side, side, side triangle congruence theorem. And I'm using a little bit of abbreviation, math abbreviation there to speed it up. But this definitely is not enough to give you the full gamut of triangle congruence problems that can arise here, but it gives you an idea of what to look for. You will need to practice doing problems in the book, doing problems in your practice worksheet, or doing problems in class with a teacher. So make sure to take the time to practice this. You do enough and this becomes pretty straightforward. Again, we have side, 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 when 3 sides are congruent to their corresponding sides in the triangle, or side, angle, side, but again, make sure the angle is in between the sides. That's very important there. You'll learn 2 more of these in the next couple sections, and you'll have 4 total triangle congruence theorems for the chapter. So hopefully that helps you out. Good luck.